recipes for creating reusable and easily updatable code. So think of design pattern as a simple, like, a way of programming so that our code is not only reusable, meaning we are writing as less code as possible, but tomorrow if we need to make any changes, we can also make minimum set of changes, right? So for example, just to give you an idea how important design patterns are, okay? So in programming, okay, the book, the most popular book, I should say, by number of copies sold, okay, is something called Design Patterns, Elements of something, I forgot the full name of it, but anyway, Elements of Design Reuse or something, right? So there are 4 authors who created this book, and they are often known as Gang of 4, okay? So in fact, if you work for any large organization, okay, most large organization on your day one on your job, if you were hired as a software developer, will give you a copy of this book, that your job is to go through and learn this book, okay? So anyway, some of the popular design patterns I'll also like to teach you so that you are familiar with those, right? One of the, and gradually I'll introduce these to you. Okay, one of the key concepts in these design patterns is, so key idea in each design pattern is to start with an interface. So before you write the code for any class, you identify what kind of methods you will need, and you define an interface. Okay, so what is an interface? Interface is simply a collection of prototypes. Okay, or you can think of it or signatures of methods. Okay, so just the name of the method, what input it takes, what output it gives, no code in it. Okay, so now let me go to our database example and show you that first what we'll do is we'll create an interface. Okay, then we will provide an implementation of the interface. And the benefit, as I will show you later on, is tomorrow, what if somebody says, no, we don't want to use SQL Server, we want to use MySQL. And I'll show you that by just changing one line of code. If you programmed it properly using design patterns, you can easily switch from SQL Server to MySQL or Oracle or whatever you feel like it, right? Okay, so let me introduce interfaces now. Okay, so in fact, so what I'll do is, okay, let me, since I'm already on the computer, let me do it here. So I'll right click on name of the project and I'll say add new item. Okay, let me go to name ascending over here and locate an interface. Okay, so once you program in C#, which is, you know, every language has its own convention. If you're creating an interface, you'll name it starting with capital letter I. Okay, so let me call this interface I data access. Okay, I, capital I, data access. Okay. Okay. Now I will define 3 methods in it, corresponding to our 4 fundamental needs, right? Get single answer, get many rows, many columns, and insert, update, delete. Okay, the stored procedure is a little bit of a separate case, so I won't put it over here. We'll handle it separately. So our first method over here will be object get single answer, and it will take the SQL as an input. Okay, our second method will be data table, get many rows, columns. It will take string SQL as an input. Let me also mention, once we create an interface, as you can see, it's just the name of the method. What input the method takes, what will it return? We never say public or private before a method. Once we implement it in a class, the class decides whether that method will be public or private. Okay, so again, no public, private declarations inside an interface. Okay, so let me resolve that. Okay, quick actions using system.data. Okay, and lastly, if we are writing insert or update or delete. Okay, we'll also take a SQL as an input, which is a string, and tell us how many rows are going to be modified, right? So once we have defined the interface with these are the three methods that we plan to put over there, now we will write a class and write the code for these methods. Okay, so now let me go to the data access class that we already had added. Okay. Okay, and now this is what I'll do. I won't put this method over there. So now I will say the class implements iDataAccess. Okay, so in C#, we use the same inheritance syntax for implementing interfaces as we do for inheriting from another class, because for all practical purposes, interfaces act as the base class. Okay. So anyway, all you have to do is say :iDataAccess, right? Now we need to, that means we need to provide the real code for the three methods in this interface. So what are those three methods? We have to match the signature 100% over here. Okay, so easy way to do that is right click over here. Again, let's see if we go to quick actions, and you'll see implement interface under quick actions. And this will then end up writing the skeleton for all the three methods. So this way you cannot make a mistake in name of the method or the parameters. Okay, so right click, quick actions, implement interface. Okay, now let's go and write the code. For example, for many rows, many columns. Okay, if I go to right click on the form view code, we just had written this code. So let me just copy this code. And we'll modify it appropriately. So if I copy the same code, go to the data access. Now for get many rows, many columns, if I paste it over here. Okay, now let me change. Okay, the connection string, I will make it as part of the class. So Control X. And I'll make it a class level variable. Okay, and I'll make it a static variable. Okay, and I'll make all of these static methods so that we don't have to create an object of the class because they are fully self-contained. Each one of them takes a SQL, and then, right? So anyway, let me resolve the SQL connection, right click, quick actions, using system.data. So anyway, con.open. Okay, now SQL will be given to us by the caller. so I don't need to create SQL over here. So I'll take this out. Okay, we will have SQL data adapter and so on, da.fill, con.close, right? We're not trying to display it. We will simply return the, so let me take out the comments momentarily, because this way you can see the whole code. So, okay, if there's an error, as we discussed in our exception lecture, this is a separate class. It has nothing to do with the UI, so we'll simply throw the error back to the caller, correct? Now we'll be returning a data table. So let me create this. So let me create it above the try block because we'll be returning it. Okay, and over here, so I don't need this line. Okay, so this is our total code for, oh, I forgot to return the DT. So, okay, so anyway, this is our total code for get many rows, many columns. So we create the connection object, create a blank data table, open the connection, create the data adapter, call the fill. The SQL will be given to us by whoever calls this method. Okay? So all the details of opening, closing the connection, creating the data adapter have been encapsulated in this simple method called get many rows columns, right? Okay, very similarly, once we have written this, let me just copy the inside of this method. Okay, go to the get single answer and paste that over there and just modify it appropriately. So in this case, what will we be returning back to the caller? Object obj equal to null. See, if it doesn't find it in the database, then we should return a null. Unlike the data table, where even if there are no rows, no columns, this will be blank. So that's small difference between the two. Okay. So of course, return will be obj at the very end for a get single answer, correct? Okay, and what will we be creating over here? Data adapter or
SQL
command object, right? So SQL